Factoring by grouping. Here we're given a polynomial with 4 terms, and the directions say to factor it completely. So we'll notice that there is no common factor I can take out of all 4 terms. So let's put parentheses around the first and the second term and the third and the fourth term. So we've grouped the terms together 2 at a time. Now notice in the first group there is a common factor we can take out, a 3a squared. There was no common factor we could have taken out of the second group. However, we can write this expression with the 1 coefficient in front of the 4a minus 3. And now we can notice there is a common binomial factor of 4a minus 3 common to both. So we can rewrite the expression by factoring out that 4a minus 3, leaving us with 4a minus 3 times 3a squared plus 1. And that is the factored form of the original polynomial. The steps that we used were to group the terms 2 at a time. Then we factored out a GCF from each group. We identified there was a binomial factor that was common to both, and we rewrote it in factored form. So these are the steps for factoring by grouping that we'll be using. Let's take another example. Again, there are 4 terms. There is not a greatest common factor that I can take out of all 4 terms, so we will follow the steps we used in the last example. We'll put parentheses around the first and the second, and the third and the fourth terms. Most of the times you can just use the order that's given. We will factor out a GCF. Notice there was a p squared that we factored out of the first group, and there was a factor of 3 common to both terms in the second group. The common factor that we're going to identify is this 2p plus 5. We'll factor that out and rewrite the expression as 2p plus 5 times p squared plus 3. So the original polynomial with 4 terms can be represented as a multiplication problem in factored form, 2p plus 5 times p squared plus 3. And we use factoring by grouping. Here's another example. Always notice there's 4 terms. Notice there is not a common factor I can take out of all 4 terms. So let's group them 2 at a time. The first group has an n squared common to both, and the second group has a 3 common to both terms. Notice there is a 3n minus 4 factor that's common to both. We'll factor that out, and our answer will be 3n minus 4 times n squared plus 3. We'll try another example. This one you'll notice has 4 terms, all plus signs. Always makes it a little bit nicer. And there is no common factor, so we'll group them exactly the way we see them. Because in each group, there is, at least in the first group, there's a factor of 4n squared we'll be taking out. And we'll rewrite that second group as 1 times 3n plus 1, with an emphasis on the common binomial factor of 3n plus 1. That will help us rewrite it in factored form. Okay, one last example. Here we have 4 terms. There's no common factor. We can group these terms 2 at a time exactly the way we see them. We can pull out of the first group an m squared. Out of the second group we can factor out a 2. We can notice there is an m minus 1 binomial factor that's common to both. And so when we rewrite it in factored form, it will look like m minus 1 times m squared plus 2.